In the last section, you learned about the slopes of parallel and perpendicular lines. And remember that parallel lines are lines that have the same slope, and perpendicular lines are the lines that intersect at 90-degree angles. So that means that their slopes are negative reciprocals of each other. So anytime you want to write the equation of lines that are parallel or perpendicular to each other, that means that you have to pay attention to the slopes of those lines. So anytime that you are given a question that's dealing with parallel or perpendicular lines, I want you to immediately start thinking about the slopes of those lines. So let's take a look at example 1. And in example 1, we're asked to find the equation of a line that is perpendicular to y equals 3x plus 1 and passes through the point 9, 1. So before we actually start writing the equation, I just want to sketch. Let me use some different colors here. I want to just sketch this line first, just so that we can visualize what this problem is asking us to do. So I'm going to actually call this line L1. Okay, are you okay with me calling that L1? So L1 is 3x plus 1. Let's go ahead and plot that. So we know that that line has a slope at 0, 1. Excuse me, not a slope, a y-intercept. So it has a y-intercept at the point 0, 1. And then I'm going to start with my y-intercept and then use the slope. So here's my slope. I'm going to call that m sub 1, so we know it's the slope of line 1, as a slope of 3. And I'm going to write that as a fraction, 3 over 1. So I know that from this point here, I'm going to rise 3 units, 1, 2, 3, and go over 1 unit. But that's the same thing as falling 3 units, 1, 2, 3, and moving to the left 1. So now I'm going to connect these points of the line, and I'm going to try my best. Okay, let me try again to get a straight line through these points. Okay, let me try one more time. All right, you guys get the idea, right? So let's call that L1. Now, my goal is to try to find the equation of a line that's perpendicular to this blue line. Now, would you agree with me that there is an infinite number of lines that I could draw that would be perpendicular to L1? So each one of these that I've drawn here, if they hit that blue line at a 90-degree angle, you would agree with me that I've just drawn 4 lines that are perpendicular to L1. Right? But we don't want just any line perpendicular to L1. We want a very specific line. We want a line that passes through the point 9, 1. So, right, even though there's an infinite number of lines that could be perpendicular to that blue line, I'm looking for the one that goes through the point 9, 1. So I'm going to use red here. That's this point here. That's 9, 1. I'm looking for the equation of the line that goes through, goes through this point. Let me try again. Goes through this point and hits L1 at 90 degrees. So I want to know, what is the equation of that red line? So I'm going to call this red line L2. And our goal is to come up with some equation, some y equals mx plus b for line 2. So hopefully you can see that it looks like there's a y-intercept that happens somewhere around here. But I don't want to use my drawing to estimate that or to write that y-intercept, because my drawing is terrible, right? It's not really drawn to scale, so who knows exactly where it hits it. But we can kind of see that it's definitely going to be a positive number that's bigger than 1. And what do you notice about the slope of line 2? When you compare it to line 1, can you see that line 2, its slope has to be negative? Because look at that red line, it's decreasing, right? Whereas the blue line is increasing. So the blue line has a positive slope of 3. That means that this red line, it must have a slope, so I'll call it slope M2 for line 2. Its slope has to be the negative reciprocal of line 1. So if the slope of line 1 is 3 over 1, then the slope of line 2, it has to be negative 1 over 3, because that's the reciprocal of 3 over 1. So notice that now we have the slope of this line that we're trying to write the equation for. And to write the equation, all I need is the slope and 1 point. Well, don't we know at least 1 point on that red line? And the answer is yes. We know that the point 9, 1 is on that line. So now that you have a slope and a point, you can use either the slope-intercept formula or the point-slope formula to write the equation of that line. So I'm going to use the point-slope formula. So that's y minus y sub 1 is equal to m times the quantity x minus x sub 1. So this is 9 is x sub 1 and 1 is y sub 1. So now let's go ahead and substitute everything that we have into this point slope formula and find the equation. So I'm going to bring down this y. I'm going to substitute 1 in for y sub 1. Our slope is negative 1/3. And then x minus 9. Now let's distribute that negative 1/3. So that's negative 1/3 x plus 9 over 3, which is the same thing as 3. Okay, so here, negative 1/3 times negative 9 is positive 9 over 3. Okay, and I just simplified that. 9/3 is 3. I'm going to bring down the left-hand side here. And then my last step is to just add 1 to both sides. So we get y is equal to negative 1/3 x plus 4. So the line that's perpendicular to 3x plus 1 is the line y equals negative 1/3 x plus 4. So look at my drawing. My drawing is terrible. If I had drawn this to scale, actually, right, that, let me use red, this is actually the y-intercept of the line that is going to be perpendicular. So it's not this line here. Okay. It's actually going to be this line here, and it still goes through the point 9, 1. So there's L2, and that's it.